All right, so I'm going to go over all these questions that are listed here. Everyone who did send in their questions, I'm just going to go through every single one, even if some of these are pretty similar to each other. So it's going to go through them all. The way I'm going to do this is I will do all the questions off to the side. So I'll list the question number here, write the question out. So this way you can easily skip around and see what question I'm working on at that time. All right, so let's go ahead and get started. And we'll do question number 2 first, which is 9y cubed over 3y. So when we're doing this, we first just want to see, well, what operation are we asked to do here? And we know fraction bar means division, so we are going to divide. And I'm going to highlight my likes with my likes, because remember I said it can help us to realize what it is that we need to simplify with, and then also just to make sure we're not missing anything. So we first treat 9 over 3 like it is just a regular problem, and 9 divided by 3 is 3. So I know that that will reduce to 3, and I can cross that out. Well, y cubed over y, we know that this has a power of 1 when it's not written, and our rule for division is we subtract. We have more in our numerator to begin with, so I know I'm going to have my final answer be in my numerator as well, and 3 minus 1 gives me 2, so then it will become 3y squared. All right, so for this problem, we have 5x to the negative 5th power. So we look and see it's not in parentheses. So the only thing that's being raised at negative power right now is that x. So that 5 is not going to move. It will stay in that numerator. And in order for us to make that power positive, we need to take its reciprocal. So we need to flip the position it's in. And since it started in its numerator, that means we need to end it in our denominator. So this is 5 over x to the 5th power. All right, so for this one, it's just trying to make sure that you guys are understanding the zero power property, but also the difference between when it's in parentheses and when it's not. So here, everything is in parentheses. So all of this is being raised as 0 power. So this entire thing, expression, or I'm sorry, this entire term is going to change into 1. So it's minus 1. Well, anything raised as 0 power is 1, and it's 5 to the 0. So that is going to be 1. So this will become plus 1. And here, the only thing being raised to the power of 0 is x. So this is actually 2 times 1, which is going to give me 2. 2 plus 1 is 3, minus 1 is 2. So our final answer for that is 2. All right, so for this problem, we're now starting to combine a few different rules into one. But same thing, I'm going to go through and highlight all my likes with my likes. So I'm going to highlight my coefficients. I'll highlight my x's the same color, and I'm going to highlight my y's the same color as well. Now I'm just going to go through and just perform the operations. So 3 times negative 9 gives me negative 27. And now our rule when we're multiplying is we add our powers. So x to the 4th times x squared, well, I will do 4 plus 2, which is equal to 6. So it becomes x to the 6th power. And then for our y's, it will be 5 plus negative 3, which is equal to 2. So it becomes y squared. So our final answer for that will be negative 27x to the 6 y squared. I personally like to leave everything as is, perform the operation of rules, and then if this 2 were to become negative because I had more negative exponents, then I would get rid of that negative at the end, because you'll see we didn't need to get rid of the negative here because it worked itself out just through the problem itself. All right, let's move on to the next one. All right, once again, I'm just going to go through and highlight all of my like parts or pieces with each other. So this way I know that those are the ones I'm going to eventually look to simplify with each other. All right, now I'm just going to go through and do it piece by piece. 6 over 18, we treat that like it is just its own fraction. And I know that that's going to reduce to 1 over 3. So since I have a 3 in my denominator already, I just created the fraction bar and put 1 over 3. I'll cross out those coefficients, and now I'm going to move on to my m's. I asked myself, where are there more to begin with? Well, 8 is greater than 2, so I know I'm going to have more m's in my numerator. And 8 minus 2, because that's our rule for division, is 6. That means I will have 6 m's left, so I have m to the 6th power. I can go ahead and cross those out. I have n to the 6th in the numerator, n to the 18th in the denominator, so I have more n's in my denominator, so I know it's going to end there. And since I'm asking that question to begin with, I can do my denominator minus my numerator, and 18 minus 6 is 12, and that means I will have 12 n's left in my denominator. So then I'll go ahead and move on to my p's. Well, I have more p's in my denominator, so I'll write my answer there. And 8 minus 4 is equal to 4, so I will have p to the power 4 left. Since I did this piece by piece, I can leave that 1m to the 6, or if I really didn't want to do that because we don't need to write the 1, we can get rid of it if we wanted to. But this will be our final answer. And whether you write that 1 in front or not, you are still fully right. Just make sure you're putting it all under one fraction. All right, let's move on to the next one. All right, so this next one, there's multiple ways you can go about and doing solve this. You don't have to do it in the order I'm doing now. You can get rid of that power of 2 first if you really want to. However, I'm going to simplify my fraction first, so this way there's less things I need to multiply. So I'm going to simplify what's inside there first. 3 over 2 cannot be simplified at all, so that will remain 3/2. I have more x's in my numerator, so that means my x's will end up in my numerator again. 8 minus 6 is equal to 2, so I have x squared. Then I move on to my y's. I have more y's in my denominator, so I'll write my y down there. 12 minus 7 is equal to 5, so I have y to the 5th power. And this still needs to be squared. But now by reducing it first, I don't need to worry about reducing anything at the end. Now I just am going to apply my power to a power rule. So we will square 3, so 3 squared is 9. And our rule of power to a power, we multiply, so I have x to the 4th. Then I'm going to square the 2, so that's 4. And my rule of power to a power, I multiply, so I have y to the 10th. And that will be our final answer. All right, so for this problem, we do need to make sure that we're doing this one first before we can multiply, because in PEMDAS, exponents comes before we multiply. So I do have to do this first. So I'm going to apply my power. Well, -3 squared is equal to -3 times -3, so that will give me a positive 9. My rule of power to a power is I multiply, so that's understood to be x to the first. 1 times 2 is 2. Here, we will do -3 times 2, which is -6, and 5 times 2, which is 10. So I first raised everything to that second power, and now I'm going to bring down the other part of my problem, and we will then multiply last. Let me just rewrite this. This one, though, you had to go in that order. And now, once again, I'm going to just highlight all of my likes with each other. You don't have to do this part. It's just something I think could be helpful until you guys get like fully comfortable with it. So I'm just reminding myself of 4, and I'll start crossing things out. So now I have 2 times 9, which is going to give me 18. So I know it's 18. I'll cross that out. Well, I have x at -6 times x squared. Well, I know that my rule is adding, and -6 plus 2 is equal to -4. So I have x at -4. Y, I then have 8 plus -6, which is 2. So I have y squared. And my last one with z, I then have 4 plus 10, which is 14. So z to the 14th. However, I'm not done just yet because I see I have a negative exponent. So my last thing I need to do is to rewrite this so that this way it is without any negative exponents. So we will then have 18, because that's all of these are positive exponents. So they're staying where they're at. So 18y squared, z to the 14th. And then that x, I need to rewrite in the opposite spot. I need to take its reciprocal. So since it was originally in the numerator, I need to drop it to the denominator. And that will be our final answer. All right, so for this problem, there are a lot of different ways that we can go about doing this. I'm first just going to simplify everything I can inside of this fraction first, and then I'll worry about that negative exponent at the end. It's really up to you. There's no rhyme or reason for why I'm doing it this way. I just decided that this is the way I'm doing it for this problem right now. So I'm going to keep this raised to the -2 power. Well, 20 over 15, I know that that can reduce because both of those are divisible by 5, so it reduced to 4 over 3, so I'm going to write 4 over 3. Then here, I ask myself, where do I have more x's, in my numerator or my denominator? Well, 9 is greater than -4, so I have more x's in my numerator. And 9 minus -4, because that's our rule with division, it turns to plus, so now I have x to the 13th power. And then I move on to my y's. Well, 17 is greater than 3, so I will have more y's in my numerator. So now I will write 17 minus 3, which is equal to 14. So it's y to the 14th. And then z's, they're both negative. But -5 is greater than -8. So I still have more z's in my numerator. And then I subtract with my greater minus my smaller. And you'll see, as long as if you're doing this part right, you're still going to end up with that positive. So that turns to a 3. And since there was more in my denominator, that means, more in my numerator, that 3 needs to end up in my numerator. And I don't need to worry about a negative or anything because the subtraction took care of all of that. All right, now I simplified. So now I'm going to get rid of this negative 2. And I'm highlighting that. And we know to get rid of a negative power, we need to take its reciprocal. So 3 over 4x to the 13th, y to the 14th, z cubed. And now it's all being raised to the second power. And now after doing this, I'm just going to distribute this power in. Well, 3 squared gives me 9. 4 squared gives me 16. And our rule of power to a power, we know we multiply. So 13 times 2 is 26. 14 times 2 is 28. And 3 times 2 is 6. There are different ways you can do this problem. You could have distributed the negative 2 power in first. You could have flipped it first. You could have did a lot of different things, but it's up to you. That's the way I did it for this one, and hopefully it made sense to you. All right, we have a few more questions left before we're done with this video. All right, so for this problem, I'm going to simplify everything inside my fractions one at a time. So this 2 over 8, I know will reduce to 1 over 4. So I'm going to start with that fraction now, 1 over 4. I'll cross that out. This x to the 4th over x, well, I know I have more x's in my numerator, so I'm going to end up with x's in my numerator. And since I know I'm going to have something else in that numerator, I'm going to get rid of that 1 and just put the x. You can leave the 1 there if you want to, but we don't have to. 4 minus 1, because that's what this power is understood to be, is 3. So now I have x cubed. I have more y's in my numerator, so my y will finish there. And 6 minus 3 is equal to 3. So I have y cubed. Now all of this is still being squared, so don't forget that. And then I'm going to go ahead and simplify the other fraction. Well, there's no number to simplify with that 10, so I have 10. When I look at my x's, I see that I have more x's in my denominator, so then I know my answer of my x will end up in my denominator as well. And 9 minus 2 is equal to 7, so I then have 7 in my denominator. For y's, I have more y's in my numerator, and 12 minus 1 is going to give me 11, so I have 11 y raised to the 11th power. Now, before I can do anything else, I need to go ahead and get rid of this power of 2. So I'm going to distribute that into everything. Our rule with exponents is we multiply, so it becomes x to the 6, y to the 6. But when it's an actual number, make sure you're squaring it, and 4 squared is 16. All of this is still being multiplied by 10 y to the 11th over x to the 7th power. Now, when we do this, we could combine this into one fraction if we wanted to, or we can just think about our rules separately. So what I mean by that is here I have a x in my numerator and an x in my denominator. So I can treat them as if it is x to the 6 over x to the 7th. We can combine them into one. So I asked myself, well, where are there more? Well, there's more x's in my denominator, so I know x is going to end up in my denominator. And 7 minus 6 is 1. I don't need to write the power of 1, so I did that. I move on to my y's. Here, they're both my numerator, so I'm just multiplying them. And I know then that my y is going to end up in my numerator. Our rule when we multiply is we add, so that gives me 17. And now I'm looking at 10 over 16. Well, how does that reduce? Both of those are divisible by 2, so we will then get 5 over 8, and that is your final answer. All right, so for question number 14, there's multiple ways we can go about doing this. I don't want to confuse anyone by doing it all at once, so I'm just going to do it piece by piece. But I'll show you what I mean by doing it all at once, kind of after we go through it. So I'm just going to simplify my numerator first. Right? So I'm going to multiply my likes with my likes. So my 3 times 7 will give me 21. A times A, well, we know that we add. So 7 plus 2 is equal to 9. So we have 21A to the 9th. And then B's 4 plus negative 8 is equal to negative 4. So we have B to the negative 4 power. And then it's still all over top of 9A to the 5th, B to the negative 2. All right, so now once we simplify that numerator, we can go ahead and simplify the whole fraction now. So we're going to look at them piece by piece. So we have 21 over 9. They're both divisible by 3, so I know that's going to reduce to 7 over 3. And now we look for our like pieces or like parts. So we have A in our numerator and our denominator. We ask, where do we have more? There's more A's in our numerator, so we know it's where it's going to end. Our rule is when we divide, we subtract our power. So 9 minus 5 gives me 4. So I have an A to the power of 4 left over in my numerator. And then remember, even though for B right now, they're both negative exponents, it doesn't matter we still are applying the same logic as we were before. Where are there more? Well, -2 is greater than -4, so I have more b's in my denominator, so that's where our b's are going to end up. And -2 minus -4 turns to +4, so that gives me a +2, so we have b squared in our denominator. So what I was saying at the beginning of this problem about you can do it all at once is I didn't need to multiply 3 and 7 first. Since I know 3 and 9 can reduce, I could have reduced that first, which is then going to leave me with that 7/3 that I ended up with anyway. And then since I see I have a's in my numerator and in my denominator, I can apply the rules as I'm going. Well, when I'm multiplying in the numerator, I'm adding my powers, so it's 7 plus 2. And when I'm dividing, I'm subtracting, so I could do 7 plus 2 minus 5 right from the jump. And 7 plus 2 minus 5 gives me that a to the 4th. So for this one, if we're going to do it all at once, we can't apply the where they're more at in the beginning. If we were, then we would just have to do subtraction in a little bit more of a harder way. So for this one, I would just say that I'm starting and just going to apply it with my b in my numerator. So I'm going to multiply, which means I'm adding. And then I'm going to subtract that -2 at the end. So then this will give me a -2. So that means that our b would have ended up in our numerator as -2. And then we would have just got rid of our negative by flipping it and taking its reciprocal. All right, let's go ahead and move on to the next question. All right, so for this one, we're going to just go ahead and get rid of both of these exponents because we can't multiply still until we do that. So here we have 3 squared, which is going to give me 9. And our rule of power to a power, we multiply. So 6 times 2 is 12, and 2 times 2 is 4. So now we got rid of that power of 2. And we're now going to cube. Now remember, when we're cubing, this means -2 raised to the third power, which is -2 times -2 times -2. This gives me a 4 times -2 is -8. So when we're cubing something, the sign stays the same. Anytime we raise something to an odd power, whatever sign the number began with is a sign that the number will end with. And even, it's always positive no matter what. So this is now -8. Well, 3 times -3 will give me a to the -9. And 6 times 3 gives me b to the 18. So now we're going to go ahead and multiply these two parts together. Well, 9 times -8 is -72. When we're multiplying our a's, we're going to add. Well, 12 plus -9 is equal to 3, so I have a cubed. And 4 plus 18 is equal to 22, so I have b to the 22nd power. And that is our final answer. All right, so for this one, we need to perform or do our power first in our numerator. So now I have 2 cubed. Well, 2 raised to the third power is equal to 8, so I have 8. Our rule of power to a power, we multiply, so it becomes x cubed and y to the 6, all over top of 4x, y to the 6 as well. Well, 8 over 4 I know is going to reduce to 2. I have more x's in my numerator, so my x's will end there, and 3 minus 1 gives me 2, so I have x squared. And anytime I have the same amount, I know that they're going to cancel completely, or 6 minus 6 is equal to 0, and anything raised to 0 power is 1, so I don't need to write y, and our final answer is just 2x squared. All right, so for this one, I'm going to simplify my numerator and my denominator separately, but at the same time. So I'm going to just go ahead and multiply. Well, -7 times 4 will give me -28. A squared times a cubed, well, 3 plus 2 gives me 5, so it's a to the 5th. Let me erase this in case I need the space. And b to the 4 times b to the 5th, well, 4 plus 5 is equal to 9, so I have b to the 9th. Right, then I'm going to distribute my power in. Well, -2 cubed, as we already talked about, the sign, since it's odd, is going to stay the same, so -2 times -2 times -2 will give me -8, so it's over -8. And a to the first power raised to the third, well, 1 times 3 is 3, and 2 times 3 is 6, so I just went ahead and simplified all that first. Now, I know a negative divided by negative is going to give me positive, so I'm going to just cancel those out. And 28 over 8, well, 4 goes into both of these, 7 and twice, so I know I'm going to at least have a fraction of 7 over 2. I have more a's in my numerator, so my a's will end up in my numerator. 5 minus 3 is equal to 2, so I have a squared. More b's in my numerator, so my b will end up there, and 9 minus 6 is equal to 3, so b cubed. Right? And that is our final answer for this one. All right, so now we're moving on to the solving exponential equations. When we're doing this, we hope that our bases are the same. Well, all these problems you guys asked for help with, none of our bases are the same, so we have to manipulate. So I look and see, well, my bases are 4 and 2. We look at the larger number first and say, can I rewrite 4 as 2 raised to some power? And I know 2 squared is equal to 4, so I can rewrite this as 2 squared, and it's still being raised to the power of 3x minus 1. And since we know our rule for power to a power is we multiply, we need to distribute this 2 into both the 3x and the minus 1. So it becomes 2 to the 6x because 2 times 3x, and minus 2 because 2 times minus 1. And now that's equal to 2 to the 6x minus 2. Once we get the like bases, now I know that my powers have to be equal for these two exponential equations to be equal. So 6x minus 2 is equal to 6x minus 2. Well, once I go to move my variable to one side, I'm going to notice that both of those cancel. And now I get negative 2 is equal to negative 2, which is a true statement. So that means all real numbers or infinitely many solutions. Should say all real numbers. We usually say infinitely many. Now that we've started to learn like systems of equations, that's where we would say infinitely many. And now that we know systems, we will no longer say infinitely many in just one variable cases. So in here, we would just say it's all real. All right, but if you wrote infinitely many, you'd still get full credit for that. All right, let's move on to the next one. All right, so for this next one, we have 7 to the 5x plus 20 power is equal to 1. This is the only time, so we see our bases aren't the same. This is the only time that we actually manipulate the smaller one, and it's because it is the number 1. And I know that any single number that I have raises 0 power is equal to 1. So if I'm trying to make our bases the same, well, I can write 7 to the 0 power is equal to 1. So I can rewrite that as 7 to the 5x plus 20 power is equal to 7 to the 0 power, because I know that that is equal to 1. And by doing that, now I have like bases. So I can go ahead and say 5x plus 20 is equal to 0. And now I just solve for x. I subtract 20 from both sides. So 5x is equal to negative 20. Divide by 5. So x is equal to negative 4. All right, so for this one, we have 3 to the 7x minus 17 power is equal to 243 to the x minus 2. Well, 3 and 243 are not the same. So our goal is, can we manipulate? Can we rewrite? So we look at the larger number, 243, and can I rewrite that as 3 to some power? I know on your sheet, we didn't go this far with 3, so if you need to add things to your sheet to give you an extra power, by all means you can, but this is 3 to the 5th power. So I'm just going to simply rewrite this now. I didn't change anything with this first one, so it stays. And 243 can be rewritten as 3 to the 5th power. And we know our rule for power to a power is we multiply. So I'm going to multiply those powers together. So I still have 7x minus 17. 5 times x will give me 5x. And 5 times negative 2 gives me minus 10. Now that we have like bases, I can set my variable or my powers equal to each other and solve. So I'm going to subtract over the 5x from both sides and add over the 17. So 2x is equal to 7. And we divide each side by 2. So x is then equal to 7 halves. If you write 3.5, that's fine as well. But typically you should start leaving everything in fractions, because you'll see that the higher you get in math, the less we write them as decimals and the more we keep them as improper fractions. All right, so let's move on to the last two problems. All right, so same thing. We look, okay, our bases aren't the same. I take the larger number, 1, 2, 5. Can I rewrite it as 5 to some power? Yes, it's 5 cubed. So now I can rewrite this as 5 to 2x minus 1 is equal to 5 cubed raised to the x minus 8 power. We know our rule for power to a power is we multiply. So I still have 2x minus 1 for this one. And 3 times x is going to give me 3x. And 3 times negative 8 is minus 24. We have our like bases, so we set our powers equal to each other. That's the only way that they can actually be equal. So I'm going to add over 1. The answer key for this one was incorrect. So I get 2x is equal to 3x minus 23. So I'm going to then subtract over 3x from both sides. So the negative x is equal to negative 23, and divide each one by negative 1. So x is then equal to a positive 23, not 25 like I wrote on the answer key. All right, so then we're down to our last question. All right, same thing. We have unlike bases, so 16 we can rewrite as 2 to the 4th power. Oops. So then we can rewrite this as 2 to the fourth raised to the x plus 2 is equal to 2 to the 4x minus 5. Well, power to a power we multiply, so I get 2 to the 4x plus 8 is equal to 2 to the 4x minus 5. Now we set our powers equal. 4x plus 8 is equal to 4x minus 5. When I subtract 4x from both sides to move it to the left, I see that they cancel. 8 equals negative 5. Well, we know that's false, so that means that this is no solution. All right, that is every question that you guys asked, and that is it for this video. All right.